In this section, we will look at electrical cabling on site. We will start by looking at how we size electrical cables using the current rating and volt drop, before seeing how we can install and operate electrical cables safely on site. The aims of the course today are to show how to install cables safely on site, to show how to size a power cable based on the current and the required volt drop, to show how to connect cables together safely, to show how to install cables when a roadway is involved, to select which cable we want to use, we need to look at the data tables from the cable manufacturer. Here we have a typical cable data table. The table shows the cross-sectional area in millimeters squared, the maximum continuous current carrying capacity in amps, and the resistance per meter in ohms. We can see that as the cable cross-sectional area or size increases, the resistance per meter decreases. As the cable cross-sectional area or size increases, the current carrying capacity increases. We can use this data together with the system parameters to work out which cable we need to select for any application. Let's do a worked example. For a circuit that will carry 128 amps continuously, choose the correct cable. Here we have the table from before. All we need to do is go down the table and select a cable that can carry the current required. From the table we can see that a 50 square millimeter cable is suitable, so that's the one to go for. We always choose a cable that can carry more than the required load, so we could in theory choose a 70 square millimeter cable as well. We can see from the table that each cable also has a resistance per meter. Let's call it RC. This is a linear relationship, so as the cable gets longer, its total resistance increases by the same amount. Therefore, for a cable 3 times longer, the resistance will be 3 times higher. Let's now look at a typical circuit. Here we have a standard circuit with a live, a neutral and a load, with current flowing and voltage V source at the input. In this ideal condition, the voltage at the load, V load, equals the voltage at the source, V source. In practice, we need to consider the resistance of the cables that carry the electricity from the source to the load, RC. The cable carries current and has a resistance, therefore it must generate a voltage across it from Ohm's law. This results in the voltage at the load, V load, being less than the voltage at the source, V source. This difference is called the cable volt drop. Let's do a worked example. Using the data table, select a 125 meter long cable that can carry 92 amps and keep the cable volt drop below 10% of the source voltage of 230 volts. Step 1 is to select a cable from the table based on its current carrying capacity. Here's the cable data table from before. Looking at the table, a 25 square millimeter cable can carry 92 amps. Let's choose that one. Step 2 is to calculate the cable volt drop. From Ohm's law, voltage equals current times by resistance. Resistance equals cable length times by the cable resistance per meter. Here's the cable data table from before. We can see from the table that for our 25 square millimeter cable, the resistance per meter is 0.000727 ohms. Let's put that into the equation. Resistance equals 250 meters, which is the cable length, multiplied by 0.000727 meters from the cable table, equals 0.181 ohms. Therefore, volt drop equals 92 amps, which is the cable current, multiplied by 0.181 ohms from above, equals 16.65 volts. This means that the voltage at the end of the cable will be 16.65 volts less than the voltage at the start of the cable. Step 3 is to calculate the volt drop percentage. Percentage equals 16.65 volts from the equation above, divided by 230 volts, which is the source voltage, equals 7%. Therefore, a 25 square millimeter cable is okay. What would we have done if the volt drop had been over the 10% value shown? Well, we would have chosen the next cable size up, as it has a lower resistance and therefore a lower volt drop. Most of these calculations can now be done using software supplied by the cable manufacturers. All cables on site should be connected together using waterproof, colour-coded, industrial standard sockets. The colour of the plug-in socket depends on the voltage level. For a voltage of 110 volts, the plugs and sockets are yellow. For a voltage of 230 volts, the plugs and sockets are blue. And finally, for the voltage of 415 volts, the plugs and sockets are red. Only industrial standard extension leads can be used on construction sites. Domestic standard extension leads are not sturdy enough and will get damaged. Homemade extension leads or connector boxes are not allowed. Here are some examples of some poor quality extension leads. Unless you can see both ends of an electrical cable or wire, you should always assume that it is live, and therefore dangerous. All unterminated cables and wires are to be removed from site. Tape joints should never be used on cables as the glue fails, leaving the live conductors exposed. Here's some examples of some poor quality tape joints. The only solution is to use a proper heat shrink connection. Above ground, the industrial standard socket should be used to join cables. Below ground, heat shrink joints are the way to go, as they provide a permanent, waterproof joint which has a similar mechanical integrity to the original cable. Cables should be kept off the floor at all times. This keeps them out of standing water, removes them as a trip hazard, and stops them being damaged. The best solution is to run the cables above head height using the building structure. Here's some examples of where the cables are being exposed to damage and have also become a trip hazard. Electrical cables cause a particular hazard to metal scaffolding platforms. If the cable gets damaged and comes into contact with the scaffolding, the whole scaffolding structure will become live and extremely hazardous. When electrical works are taking place on scaffolding, we should ground the scaffolding with a copper ground rod. Try and segregate the cable from the scaffold using insulated hangers and plastic piping. Never wrap electrical cables around scaffolding. When we need to take a cable across a roadway on site, we have several options. Option 1 is to take the cable above the roadway. Here's an example of what we require. Poles are provided on each side of the road and the cable is strung between them. Additional wires may need to be strung between the poles to support the cable and stop it sagging. Option 2 is to go across the roadway surface. We can run a steel pipe across the roadway, then cover it with sand or soil to protect it. We then run the cable through the pipe. If there is only light traffic on the roadway, a cable protector can also be used as an alternative. Option 3 is to run the cable underneath the roadway. To do this, we bury a steel pipe underneath the roadway, then run the cable through the pipe. This is a more permanent solution. Burying steel pipes underneath the roadway is obviously the best permanent solution, and pipes can be installed as the site is backfilled. They can then be used for cabling as the need arises. For temporary situations, either of the other options are fine. Any installation should be checked and tested by the competent electrical person before the cable is energized. Let's summarize what we've learned today. Cables should be selected and sized using their current rating and taking into account the maximum allowable volt drop. Only industrial standard extension leads can be used on site. Domestic and homemade extension leads are banned. Electrical cables should be joined using colour-coded industrial standard sockets. When cables need to cross a roadway, the cable can either be taken above the roadway using poles, beneath the roadway in a steel pipe, or across the roadway using a cable protector. You are now nearing the end of the course and should have a good understanding of electrical cabling and the other elements that go into a site electrical network. I've attached some questions on today's section to test your knowledge.